continental drift and plate tectonics. Continental drift is the idea that the continents move around on Earth's surface. The surface of Earth is broken into many pieces like a giant jigsaw puzzle. Plate tectonics describes how these pieces move on Earth's surface. Theory of continental drift. The theory that continents were once connected, but have drifted apart. Alfred Wegener. Alfred Wegener was a German climatologist and Arctic explorer who suggested the idea of continental drift. He thought the continents we know today had once been part of an earlier supercontinent. He called this great landmass Pangaea. Evidence for continental drift. Coal beds stretch across the eastern U.S. and continue across southern Europe. Matching plant fossils are found in South America, Africa, India, Australia, and Antarctica. Matching reptile fossils are found in South America and Africa. Matching early mammal fossils are found in South America and Africa. Fossil evidence. Impressions of organisms left in rock layers that indicate the organisms once lived in the area. Matching rock types and mountain belts occur in North America and the British Isles, and Africa and South America. Evidence of glaciers is present in regions with warm, dry climates. Continents that are close to the equator today were once closer to the South Pole in the distant past. Map with fossil locations. Plate tectonic theory. Theory that the lithosphere is divided into tectonic plates that slowly move on top of the asthenosphere. Seafloor spreading. American geophysicist Harry Hess helped develop the theory of plate tectonics. While a Navy officer, Hess helped map the ocean floor. Hess called his hypothesis seafloor spreading. Undersea mountains discovered. Naval maps showed undersea mountain chains that formed a continuous chain down the centers of ocean floors. Hess wondered if new ocean floor was created at these mid-ocean ridges. Harry Hess idea. As new seafloor is made at mid-ocean ridges, the continents are pushed away. Seafloor spreading evidence. A parallel pattern of rock material found at identical locations on each side of the mid-Atlantic ridge reveals rock of the same geologic age and polarity. The key was the discovery that there are magnetic patterns in the rocks on either side of the mid-ocean ridges. Reversed polarity. Normal polarity. Lithosphere. Cool, rigid, outermost layer of Earth that is divided into enormous pieces called tectonic plates, consists of the crust and the rigid uppermost part of the mantle. Earth's tectonic, lithospheric, plates. Moving pieces of the lithosphere. There are two kinds of lithospheric plates, oceanic plates and continental plates. Andesite, granite, and basalt are all igneous rocks. Basalt is a much denser igneous rock than andesite or granite, so oceanic crust is more dense than continental crust. Mantle convection. Convection cells in Earth's lower mantle drive the lithospheric plates on the surface. Heated lower mantle material rises toward Earth's surface. Then, cooling makes the nearby material denser and it sinks deeper into the lower mantle. This sinking process is called subduction. Hot spots and island chains. A single hot rising plume, called the mantle plume, can cause a volcanic eruption in the plate above it. If the eruption is strong and lasts long enough, the volcanic eruption may form an island on the plate. Hot spots and island chains. After the island forms, the movement of the plate carries it away from the mantle plume. Scientists determine the direction and speed of plate movement by measuring these island chains. Plate boundaries. There are three types of plate boundaries. Divergent boundary. Great Rift Valley in Africa. Mid-ocean ridge. The boundary between two tectonic plates moving away from each other, on land creates rift valleys, on the seafloor creates new ocean crust. Divergent plate boundaries. Divergent boundaries are found in the ocean as mid-ocean ridges. A divergent boundary is the line between two plates where they are moving apart. This type of boundary is found over the rising plume of a mantle convection cell. Divergent boundaries. Divergent boundaries can also be found on continents as rift valleys. When a rift valley forms on land, it may eventually split the land mass. Convergent plate boundaries. Convergent plate boundaries are where two plates come together. When continental plates collide, mountains are formed. When an oceanic and continental plate collide, the denser oceanic plate subducts under the less dense continental plate. When oceanic plates collide, one subducts under the other, forming a trench. Convergent boundary with mountain building. Continental plate. Crust. Lithosphere. Asthenosphere. A major geological event occurs when continental plates of equal density converge. Convergent boundary with subduction. Volcanic mountain range. Some oceanic crust melts and forces its way upward. The boundary between two tectonic plates moving toward each other, resulting in volcanic activity when a denser ocean plate subducts below a less dense continental plate. Subduction. Subduction zone. Note the formation of a trench in the subduction zone. A plate is forced below when one plate is denser than another as they converge, occurs at continental to oceanic boundaries and oceanic to oceanic boundaries. Collision of Nazca and South American plates. As the oceanic Nazca plate collides with the continental South American plate, the denser Nazca plate subducts under the South American plate. The resulting surface feature is the Andes mountain range. Subduction zones and volcanic activity. Volcanoes often occur at subduction zones. Convergent boundaries and mountains. Mountain ranges are formed when continents collide. Formation of the Himalaya Mountains. The formation of the Himalaya Mountains is attributed to the collision of the Indo-Australian plate with the Eurasian plate. Transform boundary. The boundary between two plates that slide past one another. The release of stored energy result in sudden shifts, often causing major geological events such as earthquakes. Transform boundaries. An edge of a lithospheric plate that slides by another plate is called a transform plate boundary, sometimes called a transform fault. Transform plate, fault, boundary. A good clue for locating transform boundaries is offsetting. When seen from above, the feature appears to make a zigzag.